Welcome friends, I am Mr. Harshal Warade, Assistant Professor from Sanjini College of Engineering Kopergaon. Welcomes you for this new lecture, that is laser metrology or lasers in metrology. So let us learn lasers in metrology or laser metrology today. We know that we need to inspect the components which are manufactured there in the organization or company. So there exist different inspection techniques. One such technique is contact and non-contact type inspection techniques. So let us see firstly the contact and non-contact inspection techniques. Inspection techniques can be divided into two broad categories. First one is contact inspection, second one is non-contact inspection. So in contact inspection, the physical contact is made between the object and the measuring or gauging instrument. Whereas in case of non-contact inspection, no physical contact is made with the measuring or gauging instrument. So one such technique is laser metrology. So applications of lasers in metrology is nothing but the laser metrology. So laser light beam is highly monochromatic. The light has a single wavelength. See, monochromatic, mono means single, chrome means color. So single colored, and single colored light is always having single wavelength. So when light is having single wavelength, then it is going to produce only a color of or the light of particular color. So that is highly monochromatic light is there. So that is laser beam or laser light. It is highly collimated. The light rays are parallel to each other. So these properties have motivated many applications in measurement and inspection. See, light amplification by stimulated emission of radiation. This is what is the full form of laser, or in short we call it as laser. So these laser beams are highly monochromatic, coherent and unidirectional. Also these are very high energy density electromagnetic beams. Lasers can be used in metrology for inspection purpose. Laser inspection system allows the measurement of the part while it is being manufactured with 100% accuracy. Laser systems have wide dynamic range, high contrast and low optical crosstalk. Following are some of the laser techniques which can be used there in metrology for measurement purpose. Scanning laser gauge, then photodiode array imaging, diffraction pattern techniques, laser triangulation sensors, 2-frequency laser interferometer, laser scanning gauge, and gauging with diameter from diffraction pattern from a formed in a laser. So these can be the different applications of laser in metrology. Let us learn some of the systems which are important from laser metrology point of view. Scanning laser system. The figure shows scanning laser system. Scanning laser system for measuring the diameter of cylindrical workpart. The time interruption of the light beam is proportional to the diameter d of the component. Now see, this scanning laser system consists of a light source, that is laser. There is one rotating mirror as shown in the figure. This rotating mirror rotates through particular angle. It is going to rotate, and there are collimating lenses. One is collimating lens and other next to collimating lens there is collecting lens, and in between collimating lens and collecting lens there is a object of diameter d which is kept. Now beyond collecting lens there is a photo detector. So this photo detector detects the light rays or laser rays which are incident on it, and this photo detector is connected to the signal processing microprocessor which ultimately gives the output, that is part size. So when laser is I will say incident, laser rays or laser beam is incident there on the rotating mirror, the rotating mirror deflects those light rays or laser rays to the collimating lens. Through collimating lens the light rays or laser rays are passing and they become parallel to each other, and they are incident there on the part to be measured. Also, the part to be measured here is a uh, cylindrical part with certain diameter d. Now these light rays are obstructed by this part, and remaining light rays means lesser beam, it is incident there on collecting lens. The collecting lens is again transferring those light rays to the photo detector, and photo detector is a detector which is going to detect the light rays or laser rays which are incident on it. This photo detector ultimately gives the signal to signal processing microprocessor, and finally this microprocessor gives the output as the part size. So this is what is the scanning laser system. Scanning laser system, light beam deflected by a rotating mirror to sweeps a beam of light past an object. The photodetector on far side of the object senses the light beam during its sweep except for short time while it is interrupted by the object. This time period can be measured quickly with great accuracy by making use of uh, measuring system. A microprocessor system measures the time interruption related to the size of the object in the path of the laser and converts it to a linear dimension. So this is what is the working of scanning laser system. Advantages and applications of laser interferometers. First one is advantages, it gives 100% quality. Second is laser consumes very less power for metrological inspection. Third one is lasers can be used, or laser interferometers can be used where very high precision and accuracy are required. Second is the applications of laser interferometers for checking the movement of machine tool tables. Second one is for aligning and checking of large assembly jigs. And third is it can be used for intricate machine part measurements. So these are the advantages and applications of laser interferometers. Here are the few references which you can use for your further readings. We know that we need to inspect